Hello, my calculus doing friends. I was asked to do this problem, 3.5, number 29. It's a graphing problem, and so we'll give a try to it. The domain is something I should think about first. I sometimes forget to think about the domain first, but it doesn't have any domain issues because this is raised to the 1/3. If that had been raised to the 1/2, then I'd have to make sure that that's positive, right? So I don't have to worry about that. And a good thing to think about also is the X-intercept and the Y-intercept. And if I let X be 0, then Y is also 0. And so I'm going to just put that here. When X equals 0, Y equals 0, right? So this is 0, 0. So it crosses right there at the origin. I was looking at that and thinking about letting Y equal 0. And so if I tried that, when Y equals 0, I was thinking, I don't know if I have strength enough for that right now, but I guess I do. And but I'm not sure. I could factor out an X to the 1/3. And so if I did that, that'd be X to the 1/3. But I don't think this is going to turn out that nice. That's be X to the 2/3. Right? 1/3 times 1/3 plus 2/3 is 1, right? Minus 3. And so that would be, we already got the 0, right? So 1/3, X to the 1/3 equals 0. X to the 2/3 minus 3 equals 0. So X to the 2/3 equals 3. And then I could raise both sides to the 1/3. So then that would be that X equals squared equals 27. And then I could take the square root. Now when you take the square root, you have to do the plus or minus. So X equals plus or minus the square root of 27. So X equals plus or minus 3 square roots of 3. So I was thinking I didn't have the strength for that, but it turned out I did. So we have another intercept here, plus or minus 3 square roots of 3. That's the X value, comma 0, right? So this and this are the intercepts that we have. Now the other thing that I would want to know is like where the local min and the local max are, where it's increasing and decreasing, and those kind of things. Now they were asking me to find all that stuff and graph it, and so I'm gonna go find the first derivative. So and do all the stuff with it. So Y equals 1 minus 3 times 1/3 X to the 1/3 minus 1, right? So that's Y prime. Y prime equals 1, and then this is 1 minus, so that's just going to be, this is 1, so this is just going to be X to the negative 2/3. Okay, so we want to find where Y prime equals 0 and where it's undefined. I'm going to write this as 1 minus 1 over X to the second. I don't know why I said X to the second, X to the 2/3. I'm thinking about getting a common denominator. So I'm thinking about writing this 1 as X to the 2/3 over X to the 2/3 minus 1 over X to the 2/3. This is my Y prime. So this is X to the 2/3 minus 1 over X to the 2/3 as Y prime. So when I set this to equal, when I set this to equal 0, Y prime equals 0, that's X to the 2/3 minus 1 equals 0, or x to the 2/3 equals 1. So I could raise both sides to the third like I did here on that other one, and then I would get x squared equals 1, and then I could take the square root of both sides, so plus or minus 1, right? So when I take the square root of both sides. Now this is undefined. That's another place that I could have some critical points. That's when x to the 2/3 equals 0, so that's x equals 0. So we have all these critical points, and I'm going to put those critical points on a number line. And remember that we didn't have any domain issues. So I want to know, and this is, I'm going to be testing for my first derivative, and I want to know where is it positive and where is it negative. And I'm going to be testing either here in my first derivative, so either here, or back in any of those, whatever you think would be good. And so it's your choice on that, totally. Whatever you think would be good. So if I check in a negative here, now when I square, that raised to the 2/3 is going to ultimately have a square in it. And I'm thinking about putting it in my calculator because I have to tell you guys that I am really tired. And so I feel like I'm going to test -2. I feel like if I'm not careful that I'm going to make mistakes. And so, so 2 divided by 3. And this way, since I have several regions to check, I'll only have to put in 2/3 this a few times. So I just checked -2, and I found out that it was positive. So that means it's increasing. Then I'm going to check something like -1/2 or anything in here. So actually just putting -0.2, just adding a decimal point would be in between, and that would be less work than putting in -1/2. So when I do that, I get negative, which means it's decreasing. I'm going to just put DEC for decreasing. Then I'm going to put in 0.2, somewhere between 0 and 1, because all I have to do then is remove the negative. And I got negative. And if you're thinking, did I expect that it wouldn't alternate regions? And the answer is decreasing. There I am putting it in. The answer is, actually I sort of did, because right here, this was x to the 2/3. When you think about that, this is x to the 1/3 raised to the second. And so this is a repeated root multiplicity 2. And whenever it's multiplicity 2, then it's not going to alternate around that root. And so I actually might have known that it wasn't going to alternate. And now I'm going to check 1, something above 1 rather. So I'm going to check 2. So all I have to do is remove that decimal point, and I can check 2. And your book shows you, so that's positive, your book shows you some ways of doing it using the sign tables and whatnot. And that's fine too. That's cool. I don't care. Doesn't matter to me. So it's increasing, decreasing, decreasing, increasing. So it's going uphill, and then it turns and comes back downhill. So this right here is a local max at the ordered pair, -1. And now remember, I'm going to put this back into the equation for y. Not for y prime, but for y. So this is what y is. And so I'm going to clear out what I have in my calculator, and I'm going to put in there -1. minus 3 times. You could, of course, do the arithmetic in your head. That would be just lovely. And I get 2. Well, isn't that nice? Okay. Then here, because it's decreasing, decreasing, that's not a local min or a local max. This is going downhill and then turning and going back uphill at 1. So that's a local min at 1. And then now, because I have that in my calculator, I can go and edit. Oh, shoot. Lucky I didn't say, oh, I did it again. So, you got to be careful when you're typing. So I get -2, and isn't that friendly? Okay. Now, the next thing that they asked me about is the concavity. This thing doesn't have an asymptote. I forgot to tell you about it not having a vertical asymptote. The reason that it doesn't have a vertical asymptote is because that would be where the denominator is equal to 0 of a common fact of something that's not a common factor with a numerator. And so anyway, so I didn't have one of those. So now I'm on the second derivative and I'm feeling like I need more paper. And so here was the first derivative. I'm writing it in this form here. I get to choose any of those derivatives, how I had written it, and I'm choosing that one because that would be easiest for me to take the second derivative from there. And so the second derivative is equal to the derivative of 1 is 0, and then this is going to come down in front, so this is going to be 2/3 x to the, and then I'm going to take away 1 there. So that's going to be -2/3 take away 1, -2/3 take away 1, which would be 3/3, right? So that's -5/3. So when the dust clears here, this is 2/3 x to the 5/3. And so this is never equal to 0. Right? You would just get rid of your variable. But this, it could be undefined. That's when 3x to the 5/3 equals 0, and that's when x equals 0. So I'm going to put that on my number line, and this is going to tell me about concavity. No domain problems on this problem. And so testing in the second derivative, I'm going to test over here something like -1. So if I put in -1 into my second derivative, then raised to the 5/3, you can take the cube root of a -1 and you can raise it to the 5th. And when you do, you get a negative. So this is going to be -2/3. So this is negative over here. So it's concave down. And then over here, you can put in a +1. And when you do, you get 2/3. So this is positive. So that's concave up. And so inflection point is 0. And I think I already know that, so we have an inflection point at 0. And I've already found that 0, 0 goes together. So now I'm going to put all of this together on a graph to the best of my ability. So here comes my graph. So I want to put on here 0, 0. That was X-Intercept and Y-Intercept. And then I want to put on here 3 square roots of 3, comma 0. So 3 square roots of 3, I don't even know why I care so much where it is. But it's around 5, a little bigger than 5. So it's over here, precisely right here, 3 square roots of 3. And the same distance is -3 square roots of 3. Okay. And then we had an inflection point at 0, 0. So I think I put, we had -1, 2. So this was around -5, so -1 somewhere in here, and then up 2. And that was a local max. And then 1, so 1, -2 was a local min. And so now I'm gonna draw what I kind of know is happening about here. So I know that it was, looking back here, right? It was increasing. So to -1, it was increasing. So I know it's going to pass through that point and to go here. And I know that that is a local maximum. So it's increasing here. And what I know is happening also is that it's concave down. All the way to 0, it's concave down. So I'm drawing something that goes through, that's going uphill and going through all of those points that I have, that's concave down and uphill. So to the best of my ability, I drew that. And then it's going to go, after, from -1 to 1, it's going to be decreasing. And I know that this is an inflection point, and so that means the concavity is going to change. So this thing's just going to go like that, isn't it? And so it's going to go woo, and then up. No, that's one happy graph, I think. So we did a lovely job on it. That's the only question that I had from people. And I might be able to make another video tomorrow if you guys have more questions. So we had the review on Monday. I was supposed to have a code word. And I think my code word is going to be happy, so that I'll know if you've watched these videos. I also wanted to talk to you guys about your test. I'm going to have the test posted today or tomorrow, probably tomorrow, and it's going to be due at the end of class time on Tuesday. And all the rules will be on the front of the test. And the other thing is that because the test is unproctored and I just haven't figured out a way of proctoring the test, I've heard all kinds of stories that people are going through with proctoring. I've even experienced some of it living with a student here myself, and having to come up with ways of having tests proctored and with video equipment and everything else, and it's been very difficult. I even had a crazy dream about asking you guys to drive up to BC and park in the parking lot, and I was roller skating, peeking in all your windows. And so we'll have to do a proctored test somehow, maybe on the next test, I don't know. Hopefully school will come back. And so it was suggested to us that maybe, since it's an unproctored test, that it could be worth half of the points, and so I am going to do that. I'm going to make it 65 points instead of 130. It'll be Chapter 3, Part 1, and if we come back to school, then I'll have a Chapter 3, Part 2 that'll be in class. And so that's how I'm going to handle it. And if we don't come back to school, which I guess everyone's still mingling, I have to admit that I had to go out quickly. I didn't go to a place where there was any people. I'm so lonely for people, I can hardly stand it. But there was just, everyone was just out at the park enjoying themselves and everything. So I guess this virus is not going away anytime soon. So anyway, so I don't know if we're coming back to school or not, and if we're not coming back to school, then I'll have to make another decision on what I'm doing. So for right now, I'm going to post exam Chapter 3 for you guys, worth 65 points, and I'm going to have you guys scan that and send that to my email, and that'll all be in the directions on the test. And you don't have to print out the test. You can do it on your own paper if I know some people don't have a printer at home, and so you can print it out. and then use your smartphone to scan it. And so anyway, so those are my stories there. And you can email me if you have any questions or whatever have you on that. I might even make a video with people's questions. Okay, and so since that was the only question I had, I'm going to go with that. I'll talk to you guys later. Bye-bye.